I think we're a long way away from the last day of school. All right, so you got another minute on the bell work, and then I'll check bell work, and then we'll go over the super fast lesson on 2 different topics. There. Nope. It was already up there earlier. Should have written it down. It was up there for a full minute before I started the timer. It's, if you look at your last bell work from last class, it's pretty much the same thing. Start the last one. Oh, somebody took it.
There you go.
Oh, there you go.
Is a pack of gum your hot class?
No, they gave us that. Teachers that. They gave us TV stuff. I gotta do attendance. Attendance today is going to be in red. Let's see. Willie, I saw Willie earlier today.
I didn't see him.
Class. I
got that for sure.
Pretty sure I saw him.
Oh.
Oh, got him. I was just saying, I saw you earlier. Now you're gonna make me right here. Already ready. Myra.
Maybe it's not October anymore.
No, it's sort of.
Your birthday thing.
Oh, I can change that too. I was gonna say I changed this one. Yeah, we do have to put up the November birthdays. Oh, that means I gotta give candy out for October birthdays. I'll leave it up there
Why is this my shirt?
to remind me to do candy for October.
Like the Sharpie. Like really strong Sharpie.
Everybody in that row. Everybody in that row. All right.
Is someone using a Sharpie?
Raise your hand if you're done. Oh boy. Oh, starting over there then.
No, it doesn't mean you come over here.
Yep. Exactly what I mean.
I just got all my stuff.
Yeah.
I shouldn't have raised my hand.
What
You
is
think?
No, that's not what I want. Can't draw a picture. Did you guys not look at your last bell work? I said look at your last bell work. 2 of them are the same exact question. There you go. No. Oh boy.
You gotta
Figure it out.
You gotta
Either why.
All right, that's pretty good.
Yep.
Yeah, connect.
I'm not done. Stop!
I don't have time. We gotta go.
Then go to someone else's house. Oh my
Once I
god.
leave, I'm gone. I don't come back. Oh, it is. What? There's something more about them. What about them? There's infinite numbers everywhere. There's something specific about those.
That's all.
I'm not really sure. You need to write the questions so you know what these mean later, unless you get them all memorized. There's more to it than this. It's where it connects. I was really just looking for the definition. So the English definition. You got one of them. That's all. So that's really all. I didn't specifically say anything about the y-intercept on 3. There's something about the points you need to know. Oh. Just one. So it's actually all. And then make the left side equal the right side. Make sure you know all of those. As long as you know it, because today's lesson is based on those two questions.
I only got one.
Which one?
I think.
I mean, that's what we use it for. I was really just looking up, like, looking for the English definition.
Oh. You always use
Oh, boy, I'm gonna give you miniature credit for that.
Do I at least get some credit? Okay.
Damn.
Yeah, so we'll talk about that. That's not bad. We can clean it up a little bit. That's really all. All right. So today we are covering two very small topics, which I was going to break out into two lessons, and then maybe do a little stuff around them and take longer on them. They're super easy, I feel like. And we have a whole bunch of stuff you haven't seen in a while that I really want to cover and do like a review of that stuff before the big quiz. So we're just going to do these fast. So it's recording. If you don't follow something, you can go back and watch it if you really, really want to look at it. I think this is probably going to be the two easiest pieces of the quiz. So I'm giving you quite a few questions on this section. So just because I'm saying it's easy doesn't mean there's not going to be a lot of points. Because I feel like this should be easy points. That's why I'm putting kind of not a lot of points, but I mean, there's going to be enough points on there where if you don't do well on this, you could be in a little trouble. And if you do well on it, it'll at least get you kind of a base grade to go from for the harder stuff. I'm going to answer three first, and then we'll go back to 1 and 2. So the word intercept, I wasn't looking specifically for anything related to math even. Like intercept just means connects or crosses. Like we kind of said that when we talked about the y-intercept. But the word itself just means to cross, to connect. Intercept was something you connect, you cross it, you meet it. That's what intercept means. Now we've talked about a y-intercept already. We've sort of done x-intercept, only we didn't really call it x-intercept. But that's what we're going to talk more about today, and then we're going to kind of do a whole lesson on just intercepts in general. That'll be what we end with. But for now, let's talk about number 1 and 2. Hopefully my smartboard is working. It was acting up earlier, so we'll see. So if we have an equation, any equation, does not matter. If there's an equal sign in it, and it's an equation, then I don't want that there. Then an equation is a what? What is an equation? Problem. Can be a problem if we don't know what it is. What is an equation? What's an answer to an equation? Well, you had it. What's an answer to an equation? Oh, I can't wait today. I mean, I hate doing this kind of lesson, but again, I want to make sure we have a big review on Wednesday. Wednesday for you guys. An equation is a rule. We said the rule is always the same for an equation. The left side has got to equal the right side. Now, in this case, what that means, and this is the equation I'm talking about, it means x subtract y has got to equal 2. That's what allows us to come up with values. We didn't have an equal sign there. We wouldn't be able to say what x and y might be. And again, there's no one value of x and y that we can say. We can't say x is this, y is this. So I can come up with a bunch of values. That's what a line is. A line is also, here's what you need to write down if you didn't find this. A line is all the possible answers to the equation, which means all the possible answers that will make the left side equal the right side. We talked about an answer being a number we substitute in. It makes the left side equal the right side. Same concept. In this case, we're going to have two variables, though, and two numbers that we would have to plug in, not just one. So it's all the possible answers that will make the left side equal the right side, all the possible combinations, ordered pairs if we have two of them. So, and again, it's not one long solid thing. It's an infinite number of individual little points. And they just get closer and closer and closer until they look like a line. So with that in mind, somebody give me a value for x and y that will make the left side equal the right side. Yes?
1 and 3.
What is what? X is what? Y is what?
X is 1. Y is 3.
So that would be 1 subtract 3 is 2. Is that correct?
No.
Be negative 2. So switch it around.
Yeah, it'll be x 3 y 4.
So x3, y1. Does that work? Well, I don't know. Let's plug it in and see. If x was 3, oh, it's not working again. And y was 1, 3 subtract 1 is 2. Yeah, that works. So perfect. There's an example of an answer to that problem. Give me another one. Somebody else.
Oh.
Kayla, what's another one? Figure one out. Just got to come up with a number for x, and when you subtract y, it equals 2. Yeah, that's all you're doing. I just need an x and a y, that when I say x subtract y, it's going to equal 2. Well, if I use 4, subtract 2, that will give me 2. So that worked. Oh no! Oh wait, I can go back. No. Pablo, give me one. 6 and 4. So if you'll notice, this one's not really that difficult to do. Like, we can come up with numbers all day long when we plug them in. This is a standard form equation. Remember when we did standard form equations, that's the way we created the line. We didn't use rise and run. We didn't use the slope. We just basically plugged in a number for x and then solved for y. We plugged in a number for y and then solved for x. But what number did we use? What were we plugging in for one of the variables and then solving? If you don't remember this, is the biggest part of the quiz. So what number did we plug in? Because it made our math easier, I said. So we plugged in what? Plugged in zeros, right? We plugged in 0 for x, solve for y. Plugged in 0 for y, solve for x. So we could plug in 0 again. We could plug in 0 for x. I'm just going to do the math for you. We'd get -2. If you'll notice, I don't even have to look at the equation. You can just follow the pattern. That's what a line is. No more eating. Thought you'd just kind of finish that up. So every y value is just 2 less than the x value. So if I have an x of 0, I just need to make y 2 less than that. If I want to choose 0 for y, I have to make x 2 more than that. The pattern will always be the same in the table. It's a linear equation. That's basically what makes the line, I'm sorry, the ordered pairs line up in a line, is that there's a pattern to it. So every time, did you just eat another one after I said you weren't eating? Yeah, you did. So I'll come back there now, take another review. Why don't you put it up? Now, why don't you put that up? Because then everybody else thinks that I'm giving special treatment to people. That's why we can't do that. So, it does actually, because I don't want people thinking. So, these are the intercepts, by the way. If I plot those two values, you'll notice both of those are going to be on one of the axes. Still don't know how to say that word. I don't know if it's axes or axes. I'm pretty sure it's axes. So one of those is on the x-axis. One of those is on the y-axis. That's our lesson later today, is about the or about what intercepts are. But basically, they're points that fall on either the y-axis or the x-axis. They will always have a 0 in them, and we're going to talk about that. Every other point, though, is still an answer. It's a solution, which means it is on the line. I'm going to put this up on the board again in a second, but here's a key concept. These two statements mean the exact same thing. If I ask you, is this ordered pair a solution to the equation? It's really bright. Oh, so you can go ahead and put that up, Willie. Don't act like you don't know what I'm talking about. Just put it in your backpack too. I know you're just checking the time. My mama texted me. I know all the excuses, but you can put it in your backpack. So, if an answer, an ordered pair, is on the line, that means it is a solution. They're the same thing. So if I ask you, is it on the line? I'm basically asking you, is it a solution? Same exact thing. So I'm not sure which way I might ask you that on the quiz, but you need to know those are the same exact thing. Is it on the line is the same as, is it a solution to the equation? So if I use this line that I already created to connect those 2 points, so if I use this line to connect those 2 points, you'll see every, oh boy, I hate it when it does that. Oh, that's pretty good. Every point that we came up with an answer as an ordered pair, is on that particular line. So we said 3, 1, which is just an ordered pair, 4, 2, 6, 4, and then we already did these two. All of those are on that line. If they are solutions, they are on the line that we could graph. So we can look at 3, 1, 4, 2, 5, 3. We did 6, 4. So again, that's the main concept, those two things. Here's how you're going to get tested on it. Whether it be me or whether it be algebra next year, they're most likely going to give you something like this. Well, actually, they're not going to give you something like this, but we'll do it anyway. Stop. So if I have lines on a graph, 3 lines, can't see the green one, there's a green one down at the bottom that goes straight across. And if I say the point 5, 4 is a solution to one of those lines, which line is that a solution to? That's it. Which line is 5, 4 a solution to? Is it a solution to the equation? Because all of those lines are basically equations. I just didn't give you the equation. I just graphed it for you. Is it a solution to the blue one, the red one, or the green one? What do you think, Lupita? Red one, Kayla, what do you think? Red, what do you think, Vicky? No? What do you think, Valentina? 5, 4 is a solution. Which one of those lines? Which one of the equations that are represented by them? Oh,
I mean, I can say the answer to it.
what do you think the answer is?
The answer is red.
So, again, this is like really pretty basic. If you're not getting this, you're like not paying attention. We just said a point that is a solution is on the line. Right? We just did that. I hope you're good with that. Every point on a line is a solution. Every solution on the line or every point on a line is a solution. Every solution will be on a line. All you got to do is find where this point is. And again, if you don't know what you're doing, I'd still, like, if you have no idea, find where that point is. I mean, you hopefully can find a point on a graph. Like, don't sit there and do nothing on a quiz. That's what, or again, if you want to graduate, I wouldn't sit there and do nothing on one of those standardized tests. That's where that point is. So my best guess is going to be, it's only on one of those lines. If I had to guess a line, I'm going to pick the line it's on. I don't think, was anybody waiting? So if that is the point 5, 4, it is a solution to the equation that is represented by that red line. It's on the line. It is on the line. It is a solution. Now, here's more likely the way they're going to do it. They're probably not going to give you a line. Probably going to do this. Oh boy, that's jacked up. Close enough. They're going to give you an equation. And they're going to say this. Is this point a solution? Or they might even say, is that point on that line? And again, you're going to say, wait a minute, there's no line there. Well, there's not a line, but that equation we could graph and make a line. So they're going to say, is this ordered pair on that line? And you're going to have to know what that means. What does it mean? It's on the line. It's also what? What did we just say? I mean, the same thing. If you didn't write this down, you can write it down in a second. Sit here and watch all of your write downs. Nobody wrote it down.
What was the question? No, I literally was.
See, the more and more this happens, the less I care how you do on the quiz.
Just the fact that she was
Nobody's
staring
writing
at you the
anything
whole
down.
time.
I don't
I know.
know.
Like I literally watched none of you write almost anything I've said today. Like virtually nobody's put pen to
I
paper.
literally wrote all of it. You want to look? I literally wrote what you said.
So, what did we say? The two main points I made are what? Nope, two main points that I made. You've written nothing since the bell.
Yeah, literally, that was the answer that you said.
We're 30 minutes into class. I've said like 18 different things since then.
Okay, well, I only wrote the important things that I was listening to.
All right. Well, we'll find out what you wrote on Friday, Thursday, Friday,
Wait, it's Thursday or Friday?
Friday, whenever I see you. It's always Thursday and Friday. Which there's supposed to be a visit, and I'm probably going to get in trouble, but we had this plan weeks ago. So I'm not gonna work it. So, two things you need to understand. A solution to an equation is on the line that would be graphed, if we graphed it, and it makes the left side equal the right side. Those are the two, so write it down. This is where everybody writes down now. I'll sit here and watch you write it down. The solution to an equation will be on the line, the answer, the solution, whatever you want to call it, and it will make the left side equal the right side. Nobody wrote that. I mean, we kind of wrote it down and dealt with something, but most of you did. I wonder why we don't do well on the big quizzes. The solution, the answer to an equation is on the line that we, could graph, that we could create. And it also makes the left side equal the right side, because that's where the line comes from. It's all the points that make the left side equal the right side. Should have written that as the bell word. Now, we don't have a line, so we can't say that we just look at the line and see if that points like we just did for the red line. We don't have a line, we just have an equation, so what can we do? How do we determine if that's on the line or not?
Make the line?
We could graph it. You could absolutely graph it. If you're good at graphing and it takes you that long to graph, I'll give you graph paper during the quiz. I'm not going to give you a graph for this particular problem. But if you want graph paper, that's the way you want to do it, I'll give you graph paper. I'll put it out. So you could graph the line. If you do the line wrong, though, it might give you a wrong answer, so you got to make sure you're good at graphing, which is a whole section of the test, so I hope you're good at it. And then you could just see, is that point on the line? What's another way we could do it? Which I would say in this case might be quicker.
Finding the point?
Well, kind of, sort of. This is the point, but what could you do with that? If it's a solution, if it's an answer, what's going to happen? What would be true? Daniel, if that is an answer to that equation, if it's on the line, what would be true about it? Nah, that doesn't necessarily tell me. I mean, they're clearly positive numbers. If that is on the line, if 1, 2 is on the line that would be represented by that equation, what would be true? Elias. What would be true? I just told you two things. One of them is the answer. You just wrote it down. If it's an answer, what makes it an answer? What is an answer to an equation? What did we just say?
I got it.
You all just wrote it down unless you were faking writing.
Oh, that like
Jocelyn.
right thing.
Boy, I can't hear you. Yeah, thank you. You just wrote it down. If it's an answer, it's going to make the left side equal the right side. This is an X. That's a Y. You just plug them back in and see if it makes the left side equal the right side. That's what an answer is. The number when we so Y is 2, so I put a 2 there. X is 1, so I replace X with 1. I still have the rest of the equation, though. Don't forget about the rest of the equation. If that is on the line, the left side should equal the right side. Well, if I do the math, it doesn't. I get 2 on the left equals 3 on the right. Doesn't work. 2 times 1 is 2 plus 1 is 3. If you're not sure, I got that. So that is not an answer. Not on the line, not an answer, not a solution, whatever way you get asked on a quiz. Most of the time, I think they're going to ask you, is it on the line? What about this one? Is that one on there? Is that on the line? The math should be pretty fast on that. Raise your hand. Actually, I'll give you a second. I need to move on to the next topic. Today, or this is. All right, so we got. Yeah. So I'll give you a second to try to figure out. Is 0, 2, would that be on that line? So I'll give you a second, and then we'll raise hands. We already know 1, 2 wasn't, but maybe 0, 2 is. All right, raise your hand if you think 0, 2 is on that line. 1, 2, 3, 4. Some people are thinking, oh, now people get more confident when they see all these other hands going up. So a lot of people, raise your hand if you think it's not on the line. Nobody thinks it's not on there, so either nobody knows or you think it's on the line. Well, let's see. If it's on the line, it will make the left side equal the right side. Y is 2. X is 0. What do I get on the right? 1. Does 1 equal 2? Does that make the left side equal the right side? No, that is not on the line either. Not on the line either. Did not make the left side equal the right side. What about this? Is that on the line? Do the math. As soon as you tell me if this is on the line or not. Raise your hand if you think. Willie says yes. Willie's confident too. Is that on the line? 2, 5. Is that on the line? Raise your hand, Willie. Raise your hand. You said yeah, so hand should be up. Raise your hand if you think it's on the line. Raise your hand if you think it's not on the line. Well, we still got a lot of. This is the easy part of the quiz, people. So if you have questions, you need to be asking questions right now. All I'm doing is the same thing every time. If it is on the line, if I plug that into the equation, I've done it for the 3rd time now, and I got to move on after this. I mean, this is it. If that point, 2, 5, is on the line that we would create, like we could graph that. I may graph it in a second since we're not getting this. 2, 5 is an X and a Y value. X, Y. So I plug in those values for the variable X and Y. X is 2. Y would be 5. I still have the plus 1 because that was just part of the equation. So this 2, I'm using this 2. I changed X to 2 because that's what was in the ordered pair. And the 1 is just part of the equation. 5 became Y because that's what's in the ordered pair. 5 is the only thing on the left. 2 times 2 is 4 plus 1. That is on the line. and made the left side equal the right side, willy-nilly. So that point is on the line. I mean, if you're not getting that, you need to watch some videos or something, because that's your easy points on the quiz. That section and the next section we're going to do. We'll come back and do a little. Oh boy, let's do it now. Oh, there's another thing you have to know how to do. Shoot, I didn't do this last time. Maybe I'll show them real quick before. I also ask you to give me 1 point that is on the line. So I say, what is 1 point that's on this line? This, whatever line would be created by the graph. I don't give you a line, I just give you the equation. What would we need to do to find 1 point on the line? Again, I say if it's on the line, then it is an answer. Same thing. On the line means it's an answer to the equation. So what do we need to find for this equation? I'm just doing the top one. Y equals 4 subtract 5x. I don't even know why Stan's going to teach them. I should just record this and you guys can watch it whenever you watch it. You get out of things, what you put into them. So if you're wrong, you're wrong, but as you can see, half the class doesn't know what they're doing. So. What do I need to do? An answer would make what? What would happen? What's the definition of an answer? Yeah, make the left side equal the right side. So what do I need to figure out? I need to figure out an x. Same thing we did in the beginning for bell work. I need to figure out an x and a y that will make the left side equal the right side. You could randomly plug in a whole bunch of numbers. And that's what people, their first thought is just plug in a bunch of random numbers. But don't do that. Just plug in a value. I would normally plug it in for x. I would use 0, typically, because 0 makes my math easy. If I plug in 0 for x, and then if I solve that out, so 4 subtract 0, well, that's going to be 4. That will tell me what my y value needs to be so that the left side would equal the right side. So I plugged in, I made x equals 0, and I got a y of 4 when I did that. That's one of the intercepts, which we're going to talk about in a second. So you guys are all going to need to go back and watch this. I can clearly see we're not getting it, but all right. So that point would be 0, 4. So that would be your point that is on the line. Again, I just found 2 values, one for x, one for y. No, yeah, 57. Same concept for any equation. You need to find a value for x and a value for y that makes the left side equal the right side. You could randomly plug in values or just plug in one value and then solve for the other variable to make sure that you get the right number that you need. All right, we got to move forward to intercepts right now, though. We'll do hopefully we'll have time to do a real quick check on that at the end, so we'll see. All right, so we talked about y-intercepts. We talked about the fact that a y-intercept is what? No, it wouldn't be x equals y. Y-intercept is what? Pablo, y-intercept. Say it again. It's where the line crosses the y-axis. So every one of these has a y, every line has a y-intercept, a different y-intercept in this case. Those blue dots are all the different y-intercepts. It's where those lines cross the y-axis. I'm going to skip forward. Well, no. Well, yeah, I'm going to skip forward. what's the point? What is the ordered pair for the blue y-intercept? The blue line y-intercept. Ordered pair means an x and a y. So we need an x and a y. Leo. So again, if you don't remember how to do this from a graph, you find the x value, which is your left and right value. So if I'm trying to do this point right here, my x value is right underneath it at 0. There's -1, 0, 1. So 0 is my x, and then +5 is my y. That's the blue line. Daniel, what is it for the green line? That y-intercept for the green line. X and y. 0 and 2, right? Vicky, what is it for the red line? Right there. 0, -2. Lee, did you want to answer it? You had started to say something. Black line and Elias, what's black line?
I think that's 0, -4.
It is 0, -4. What do you notice about every single one of those ordered pairs for the y-intercept?
All of them, all the eggs.
X will always be 0. Always. Because if I'm on the y-axis, it runs up and down, so no matter where I am on that axis, x will always be 0. So, given that,
like if we're like x image.
absolutely. Fantastic. That's actually the next part of the lesson. But here's the one thing I'll mention. Here's how it's going to look on a quiz. I may not give you a graph. I may say this. I may say, is that an x-intercept, a y-intercept, or neither? No graph. How do you tell? How did you know? If x is 0 and you have a number for the y, that is a y-intercept. We just did it. You should have written down some of those, hopefully, although you didn't have the graph, but you could still create a real quick graph and make your own x and y-intercepts. I'm not going to have that available. But if you don't remember, I will give you graph paper. What else could you do? The hint was I'll give you graph paper. I give you that point. You need to know, is that an x or a y-intercept or neither? What could you do?
Y and 0 and x.
Well, hopefully you have it written down, but just graph it. Put it on the point or put it on the graph. Say, all right, I mean, you don't even need to have graph paper. Just draw an x and a y axis. You only need 2. Well, 0, 2. You do need to know where the y and the x are. 0, 2 would be right there. Well, if it's on the y-axis, it is a y-intercept. So either you can understand the rule, and the rule is if x is 0, then it is a y-intercept. Or you can just graph it. If you're better visually at seeing that, then just even if it's like, well, you'll see in a second. Even if this is a huge number, like if this was 200 and it goes way off the graph, you still know which axis it's going to be on. You know if that's a 0, 200 would be way up top. You still know it's going to be on the y-axis. You don't physically have to put it there to maybe look at the graph and say, well, I know it's going to be on the y-axis. So same concept. If it crosses the y, and I'm not going to change colors for this because we only have a few minutes. If it crosses the x-axis, which normally it will, that is an x-intercept. And we don't use that as much because it's not part of an equation. We do use it when we graph standard form because we wind up finding the x and the y-intercept. I'm going to do these really quickly for you. We have -6, 0, -1, 0 for the red line, 3, 0 for the green line, and 4, 0 for the black line. What do you notice about all those?
They all have zeros on X's.
Well, on the y's. So now every y value is a 0, which means we only have an x value, which means it is an x-intercept. So if I give you a number now, so this is what you're going to see on the quiz, exactly what you're going to see. I'm going to give you a whole bunch of ordered pairs. Some will have zeros in them, which means they're going to be in either an x-intercept or a y-intercept. And again, when I say a 0 in them, I mean the number 0, not 0.001, like 0. I don't mean 0 is somewhere in the number. I mean literally the number is 0, because it's got to be on one of the axes, whatever they're called. And the only way to do that is to be at the exactly at the number 0 for either the y or the x. So either you can then try to plot them on a graph, like just build your own graph and see where they would go on the graph, if that helps you understand. If it's on the y-axis, it's a y-intercept. If it's on the x-axis, it's an x-intercept. Or if you just write the rule down, if y is 0, then it is an x-intercept. If x is 0, it's a y-intercept. What if it's 0, 0?
And it's all zero.
Is it an x-intercept or a y-intercept?
Both.
It is both. Be both. I didn't put that on there. I'll just tell you I didn't. I feel like we struggled more with this other thing, so I'm going to skip over that one. Oh, wait. Shoot. Where is it? Oh, it's at the end. All right, really quickly, you're not going to be able to do this, but I want you to at least explain how you would do it, or I'll explain it if I have to. We were supposed to do this as the end. If I give you something like this on the quiz, what's in that box? And I says, does the point 2, 5 lie on the line y equals 3x subtract 1? What would you do?
Oh, what's this?
This one right here in the box. I'm trying to zoom in. Oh, no. There. So I give you something like all of these, like there's going to be more than one. I told you there's going to be quite a few of them on there because I feel like it's easy, so it should be easy points. I'm trying to give you some easy points. If you don't know how to do it, then I guess it won't be easy. But if I say, does the point 2, 5 lie on the line y equals 3x subtract 1, what would you do? How do you tell me yes or no to that?
Yes.
I could plug it in, and I could see if the left side equals the right side. What if I give you a whole bunch of points but only one equation? You could do the same thing, right? You could plug in each point into that equation and do it over and over again. Or what else could you do that might be faster in that situation?
Graph it.
You could graph it. If you're really confident in your graphing, you could graph the line and then just see if every point falls on the line or not. So that is, again, I consider that to be the easy points on the quiz. So if you're struggling with that, you may want to go back and watch this video. If you just look up this same, like literally look up that question, you'll find a bunch of videos on YouTube that'll go over that same exact lesson. And then the intercepts also. If you see numbers, if you see 2 numbers and there's no 0, if there's no 0, it's not an intercept at all, because it's got to have a 0 in it to be on the x-axis or the y-axis. Oh, you can't walk out that door though. Yeah, you can't. You walking out of here is just like me letting my kid leave early. So wait till it rings. If it's got a 0 in it, then you got to figure out, is it an x-intercept or a y-intercept? All right, we'll do a review. We won't cover this in the review, but we'll do a review mainly of graphing on Wednesday. Graphing and then creating equations from word problems. Yeah, I don't know. We'll see. Boy, I thought the quiz was easy, but I don't know. We'll see. 'Cause I know half the people weren't getting that.
Did you tell me to give you the,
Yeah, but you're going to
I know, but I want to begin. I don't want to go to the right? Okay, so want to keep the flower?
Who? Really?
No way.
Hmm.
Time is over.
Joy, why are you sleeping all the time? Joy, that's so unlike you. I mean, lately.
That's my other shield. Some
Okay.
kids stole my
Are
slides.
those things that plug into the, like the little holes in the?
Yeah.
What are they called?
Gibbets.
I like those. I'm gonna get some.
He has them too.
I know, I like them. I'm gonna get some. I have 2 or 3 pairs of Crocs. Joy, okay? Why are you sleeping all the time? Oh, I gotta stop the recording.